Dampness in Buildings and Diagnosis, Module 7. Replastering. Building Research Establishments, Digest 245, tells us that where dampness problem exists, it usually leads to damaged internal plasterwork, and the subsequent need for some replastering is part of the remedial treatment. This is to remove hygroscopic salt contamination, stained material, and replace using a specific replastering system to prevent any further movement of underlying contamination to the new finish. In other words, it prevents future spoiling. And indeed, this is irrespective of what damp-proof system is used as a retrofit system. So looking back then at the distribution of salts in plaster, if we've had rising damp, long-term rising damp, we will have, to a greater or lesser extent, some degree of salt contamination in the plaster. And this can affect the decorative finish, even though the rising damp has been controlled. And therefore serious consideration must be given to the removal of this potentially contaminated plasterwork. And here was a problem that turned up. This was a gold wallpaper, not real gold. I think it's a mixture of copper and iron salts. And this wallpaper was put on contaminated plasterwork. And the chappie was not very pleased when his expensive gold wallpaper turned blue due to the salts in the underlying contaminated material. It's very important that the plasterwork can resist the passage of any underlying moisture in the wall from passing to the decorative surface. This is to prevent future spoiling. And remember in this fact, when a salt becomes deliquescent, it becomes liquid and it can move as well. So then, why do we need to look at this? Well, first of all, walls take time to dry out, the theoretical figure being 1 month for each 25mm of thickness. And of course the limitations of a chemical damp-proof course itself. They are only a control mechanism. So replastering for water and salt resistant finishes, we need to use a strong sand cement based mix and a well graded sand. Renovating mortars are, in my experience, not always effective. Lime based mixes are too permeable, and so are cement lime sand mixes, and all those may lead to future spoiling. And under no circumstances should gypsum based bonding plasters be used. In some cases, replastering systems may be unsuitable, as we'll see later, and serious consideration must then be given to dry lining systems. So how can we use, or what can we use as a replastering specification? Well, this one has been around for a very long time, and it consists of 1 to 3 ordinary Portland cement to sand, and I emphasise by volume, or as they call it, traditional volume proportioning. The sand should be specified as clean, sharp wash sand, loam free. The mix should incorporate the use of a suitable waterproof or salt inhibitor, and usually there are 2 12mm coats with a finishing coat to finalise. So why do we need a strong mix? Well, let's have a look at this diagram. If we use a mix in the order of 1 to 3, then we find that the cement paste will fill all the gaps between the sharp sand. However, if we use a weaker mix, such as say 1 to 6, then what we find is that whilst the particles are well glued together, there is insufficient cement paste to fill all the gaps, so we get holes present, and those lead to permeability. So we finish up with a permeable mix which may allow water salts through to the decorative finish. The other feature that is important in a sand cement mix is the sand grade. 1 part cement requires only 0.2 parts of water for the chemical set of the cement. More water is required to make the mix workable. The workable water simply evaporates once the mix is on the wall to leave holes, and those holes contribute to permeability. The problem is simply that high fine sand with a lot of clay and silt in it increase the water requirement for workability. Therefore there is more water to evaporate, and this leads to more holes and therefore a more permeable mix. Here's some samples as run through the old British Standard 882 sieves, and you can see the different mesh sizes. The stuff at the top is the good stuff. That is excellent. It meets grade M of that British Standard. The stuff at the bottom is pretty poor. That will almost certainly start to cause problems. It will require, a mix containing that sand will require a lot more water. It contains a huge amount of clay and silt. And they're just the gradings. I'm not going to dwell on these. There's sample A, passing the different sieves, and that's what was required for grade M. That was the good stuff. Sample B, I think, was the bad stuff. It's way out of grade F even, much lower than that. So what do we require in a waterproof or so-called waterproof mix? Well, do we use a salt inhibitor or a waterproofer? Well, basically, they both do the same job. They're designed to prevent the passage of water through the material and therefore the passage of salts, because the salts are in solution. Types used in water-resistant renders: pore blockers such as Seeker 1, I believe they form silicate complexes, plasticizers and water repellents, metallic soaps, organic acid, and bitumen emulsions, which are water repellent. However, we could also use dry lining systems such as these plastering or cavity drain membranes, and they are becoming very popular. Indeed, they are far more appropriate for use in listed and historic buildings, as they are less likely to cause damage to the underlying structure should the materials need removing. And there's some plastering membrane. The one on the left, you can see, has got a nylon mesh to help bonding the material on top, and you can see the little plastic blisters that hold it from the wall. It's fixed to the wall by waterproof fixings, and there's a gentleman on the right putting any old finish over it. It's completely waterproof. What about redecoration? Well, this really applies to sand cement mixes, wet mixes. Use a permeable decorative finish. Do not use vinyl or plastic finish wallpapers. These can give problems. But just as importantly, always recommend that the decoration should be regarded to be of a temporary nature for the first 12 months. Frequently people will apply an expensive decorative finish, paint or what have you, and within a few weeks, couple of weeks, it starts to be a problem because nothing has fully dried out. Do bear in mind, of course, that the above does not fully apply to dry lining systems, because in essence they're isolated from the damp contaminated substrate. This is quite important because if you are dealing with a period or historic property, then it is highly unlikely that dense cement sand mixes will be suitable. So in order to retain the integrity of the historic background, a dry lining system is far more appropriate for the finish, and they can easily be removed without damaging the underlying historic fabric. The other important feature is beware of using lime-based materials directly on the substrate, where it is known that salt contamination and moisture is present. There is a high probability using such materials that spoiling of the finish will eventually occur. Just a couple of examples: dampness appearing on lime-based plastered wall, contaminated substrate, you can see the dampness, it's caused the spoiling. And similarly here, it was used after an injection process on a historic building. Don't use lime-based materials. Unfortunately, excellent for most uses, but not good where there is any form of dampness or salt contamination that's likely to be persistent. Rising damp above effective plasterwork. Yep, that's not that uncommon. People seem to believe that rising damp can only rise a metre, and they replaster. The replastering shuts down some of the evaporation. The damp proof course is not fully effective, and it rises above the new plasterwork. Sometimes a result like this is simply by not replastering to a sufficient height in the first place. Some plastering defects, one on the left is cement plied over a bonding plaster. It's all fallen off. Cement is strong, shrinks on drying, bonding plasters and gypsums expand on drying, and you get this contrary reaction and it blows off. Also, gypsum plasters are slightly soluble, and in this case you can see a bit of efflorescence on the surface where the water's passed through, gone into the cement. You may have started to get sulfate attack. The drawing on the right, problem in the north, no problem in the property for years. The occupant had a new cooker. They hacked off the old dense render that was designed to be used following a damp-proof course and buried the electrical cable in the wall. They used bonding plaster and there was a problem. Similarly here, dense cement render hacked off in places for retrofit electrical fittings. The original plasterwork was working fine, holding the moisture and salts back, but in this case they hacked it off to fit the electrical fittings. Finally, we get a floor wall junction problem, and the problem really exists around the base of the wall. You can see there the bridging of most things. It's not directly related to rising damp, but the water just bridges around there and goes up the wall and tends to cause the area of damage just above the skirting level. That is the end of Module 7.